Pallet by Spectro Cloud lets you deploy complete Kubernetes stacks anywhere you need it. With freedom over the Kubernetes distribution, the management model, the target platform, and the applications you want to run, control over how Kubernetes operates stays squarely in your hands. Pallet manages your deployed clusters with desired state enforcement, automated scaling and upgrades, self-healing, and much more. Our unique distributed architecture ensures that clusters are entirely self-reliant, enabling you to have tens of thousands of clusters under management through a single pane of glass. Let's take a deeper look into what Pallet can do for you in the public cloud. Pallet supports the major public cloud providers, Amazon AWS, Microsoft Azure, and Google Cloud. Both regular commercial and government-only subscriptions are supported. Pallet supports both cloud-managed Kubernetes options on EKS, AKS, and GKE, as well as Pallet-managed IaaS Kubernetes that uses the IaaS components of each cloud. Depending on your needs, you might prefer the added flexibility that IaaS clusters give you, with total control and freedom over your own Kubernetes stack, including the control plane, Kubernetes distribution, and operating system. We provide OS images out of the box to get you started quickly. If you prefer building your own images, that is supported too with the Public Cluster API Image Builder. Our friendly documentation provides all of the instructions needed to prepare your environment as a target for Pallet to use. Once a cloud is added, create a cluster profile for that cloud and you are ready to deploy. Networking and storage is not a one-size-fits-all topic. Pallet gives you a number of native storage integrations that include EBS and EFS for Amazon, Azure Disk for Azure, and GCE Persistent Disk for Google Cloud. Another storage option that can be used across all of these platforms is Portworx Enterprise. Pallet utilizes packs to make this happen for third-party add-ins, which give you a template for making integration with the cloud platforms a breeze. For networking, Pallet provides the VPC CNI for Amazon, the Azure CNI for Azure, and the VPC CNI for Google Cloud. You can also select Calico or Cilium as third-party options instead. Enterprise scenarios like EKS, custom VPC networking, and fully private clusters are all integrated into the platform. Our customers deploy Kubernetes in many different configurations, so we continuously add more supported scenarios to the platform. One such example for Amazon is IAM roles for service accounts, also known as IRSA. It helps ensure a least permissions approach to granting EKS clusters access to certain AWS resources. Pallet automates every aspect of setting up IRSA roles for you, making it easy to improve the security of your AWS environment. Another scenario is fully private clusters, where the Kubernetes cluster will not have access to the outside internet. Pallet supports setting up a private cloud gateway inside your cloud of choice in order to deploy private Kubernetes clusters that will not have any internet access. Spectro Cloud uses Cluster API to automate the provisioning, scaling, and maintenance of Kubernetes clusters in the cloud, including upgrades of the operating system and Kubernetes version. Spectro Cloud is an active and frequent contributor to the cluster API providers of these public clouds. Many customer-driven features have been contributed back to these open-source projects. Let's walk through an example cluster deployment to see it in action. The deployment wizard will walk us through the steps, starting with giving our new cluster a name and selecting in which cloud subscription we want it deployed. Next, we define what the configuration of this cluster will be by selecting one or more cluster profiles. We start by selecting an infrastructure profile for the basics, such as the OS, Kubernetes distro, networking, and storage. Next, we can add additional profiles for more functionality. Here we will add a layer with an ingress controller and a monitoring agent. While we're at it, let's also add a layer for an application. All right, that looks pretty good. Let's go to the next step. Now we get to the profile configuration page, where values for dynamic variables inside certain profile layers are shown. We can easily adjust these to our needs without having to dive into the YAML of a layer. On the next step, we select where inside the Azure cloud we want the cluster to run. The target subscription, region, resource group, storage account, and SSH key are all selected here. We will opt to deploy the cluster in an existing VPC as well, so that we can reuse virtual networking infrastructure that already exists. Now it's time to configure how many nodes and of what type should make up our cluster. As this is an AKS cluster, we only need to define the number of worker nodes. We will set this as the system pool, since we're only making one node pool in this example. 2 nodes seem fine for this cluster, using the F4's instance type and standard storage. Finally, we can select our OS patching options. I think I like patching to occur on the 1st of every month, so I will select that. If so desired, we can also schedule periodic security scans, as well as backups and custom cluster RBAC permissions. We'll leave those alone for now. Let's click Validate and see a summary of our cluster. Looking great. We even see a prediction for the hourly rate that the cloud provider will charge for the worker nodes in this cluster. By clicking Finish Configuration, we kick off the creation of our new cluster. In about 10 to 15 minutes, it will be available to use. After clusters have been deployed and running, eventually changes and updates will need to be made. Pallet has you covered for Day 2 operations as well. OS patching and upgrades, Kubernetes upgrades, and application upgrades, they're all handled by Pallet for you. During installation and upgrades, Pallet will build cluster nodes one by one, or rebuild them when it's an upgrade. Pallet evacuates workloads as needed to ensure application uptime isn't affected. Similarly, Pallet monitors node health and will automatically remediate unhealthy nodes. Spectro Cloud partnered with Amazon to add support for EKS hybrid clusters as part of the official launch of that new capability. With EKS hybrid clusters, you can add on-premises worker nodes to a cloud-based EKS cluster and facilitate hybrid scenarios. For example, you can now run an on-premises cluster consisting of all worker nodes, with the control plane being managed by AWS and running in the cloud. Another option is using on-premises hybrid nodes for the base workload and bursting capacity to the cloud as needed. Spectro Cloud Palette enables you to take advantage of these new capabilities. Palette extends management beyond just Cluster API. Using cluster profiles, you define the desired state of your entire cluster, including all the additional middleware and application layers. With Pallet, you can upgrade your applications in conjunction with Kubernetes upgrades, ensuring the entire stack evolves with your needs.